Dear students, today we will study two chapters together, that is a loci and a construction. Now, what is a loci? Loci is a locus. Loci or locus is a path tracked by a moving point which moves so as to satisfy a certain given condition. Is a path traced by a moving point. Let us assume P is a point here. One point is given, we marked as P, and I want to get a locus of points or loci which is 3 cm away from this. So I'll take a compass with 3 cm measurement, and if I start drawing, then it will come in a circular shape like this. The circumference comes like this. This is a locus of points which is 3 cm away from a point P. So if only one point is given and it should be a particular distance from that point, means we get a locus of point in a circular shape like this. Okay. Whereas instead of giving one point, if they give 2 points, that is E and B, if they want a locus of points 2 cm away from this line, then we can get a line one over this side, the other one over this side. Both of them are 2 cm away from this line. How to make 2 cm away? Keep a compass over here, measure 2 cm, draw an arc. Similarly, somewhere this side, keep it over here, draw an arc. That's it, you can see the tips of those curves. You join them. This is a locus of points 2 cm away from AB. Similarly, the other side, curve, one more curve somewhere here, and tips of those curves. This is a locus of points which is 2 cm away from this line. So we get two sets of loci which is 2 cm away from AB. For the same line, we have two lines, one this side, the other one is this side. Now, here if two lines are given like AB and CD, they want a locus of points which are equivalent from both these two lines. Then it should be a midpoint of these two lines. And we have this is the locus of points which is equivalent from both AB and CD. See, from one point we get a circle circumference like this. For a one line segment we get in both the sides. If two lines are given, that line will come in the middle. Is it okay? This is the concept of locus. Whereas, assume if a point A and B is given, a point A and B is given, I want a locus of points which is equivalent both A and B. So, first of all, keep it over here. Use your compass. Take the length more than half of AB. Draw an arc this side as well as this side. Similarly, keep it at B. Draw an arc this side and this side. Join them. You know that this is the midpoint of AB. It's a perpendicular line. So, this is a locus of points which is equivalent from both A and B. Please understand, this is very, very important for our construction. When 2 points are given, if they want a locus of points equal from both these 2 points A and B, and they mention, you bisect these two sides. Bisect these 2 points. You get a curve like this. From B, when you do it, you get this curve where they intersect. Join them. This is a locus of points equal from A and B. From this point, whatever distance, minimum distance is here, same distance will be there here. So, actually we go with the concept of congruency. This is bisected, so this length is equal to this length. Then this is a common length for both of them, 90 degrees is there. So, by SCS congruency, we can say that these two triangles are congruent, so corresponding sides will be equal. But just understand, when 2 points are given, bisect them, this is a locus of points. But if two lines are, intersecting lines are given like this, if you want to get the locus of points equal from both the lines, then draw a curve, draw an arc from this edge, keep the pointer over here, compass, and draw an arc. Now keep in this point, draw one more arc, and keep it over here now, and draw an arc where both of them intersect. From this point, draw a line. This is a locus of points, this is a locus of points equal from this line as well as this line. This is the locus of points from this line as well as this line. So this is the locus. So when two sides are bisected, or when two sides are touching some point, bisect that angle to get the locus of points equivalent from both the lines. Both the lines bisect the angle. 2 points bisect them. Perpendicular bisector you get. This is the basic concept of, especially these two are very very important for our construction. Now let us see how to get a angle bisector or a line bisector, any one among them. For example, now I want to get a side bisection, that is A and B are my points, A and B are points. So from A I draw an arc, this side I drew, then once again here this side I have drawn once again, see it is touching there. Now if I join these 2 points, if I join those 2 points, this is the locus of points equation from both of them. This is the locus of, this is the midpoint, and this entire line is the locus of points which is equal from both of them. Now let us see how to go for bisecting a angle. Let us see how to go for a bisecting an angle. Now if you can see, now angle, I am keeping that corner and drawing an arc. That arc will continue further. Then see from there one point, from here once again cut, keep it over there, then extend those two. When you extend it like this, this is the locus of points which is equal from both the lines. Hope it is clear. So this is the way you can get the points which is a locus of points which is equation from both of them. Now let us go through some other concept now. Hope these two are very very important. You need to practice bisection of the side and bisection of angle. Now let us try to understand some important questions. Construct a regular hexagon of side 5 cm, means each side should be 5 cm. Then construct a circle circumscribing a hexagon. See, circle is circumscribing the hexagon. All the traces of construction must be clearly shown. So we want to draw a hexagon with each side as 5 cm. So when you want to draw a hexagon with each 5 cm, let us see how to construct a hexagon first. Start from the beginning. Now you see. So first let us draw a line of 5 cm first. Once you draw a line of 5 cm, mark them as 5 cm. Then take your compass, just draw an arc in either side of this line, this side, and now when you drag first cut, it will be 60 degree, the next cut will be 120 degree. Similarly this side, if it's 60 degree, the next one will be 120 degree, because each angle will be 120 degree in a hexagon. Now join this, extend that line, it is for 120 degree, we are extending it. Similarly this side also you can extend for 120 degree, extend it for 120 degree. Okay. Now measure this 5 cm like this, then cut in both the sides. This side also you mark, then the other side also you must mark. So now we got 2 more sides which is 5 cm, means together we got 3 sides, but hexagon we need to get 3 more sides. Once again keep it over in C, draw once again an arc, then 60 degree, the next cut is for 120 degree. Now once you get this, you can extend once again like last time, extend this line. Okay. Now once again measure 5 cm and keep it over there. We got the 4th side 5 cm. Now 5th and 6th are left out. This is our D. A, B, C, D is over. Measure that already 5 cm you have measured. Use that and draw an arc. Once you got this arc, keep it the other side now. This point, yes, Then from there, draw an arc. See, it may not touch sometimes. You may have to come back once again and complete that arc. Yes, they are meeting here. Join those two now. Means previously we had 4, now it becomes 6. 4, this is the last point we got. Join all of them. If you join all of them, it will be a hexagon with 6 sides. Means it's a regular hexagon, all sides are 5 centimeter, and we have got exactly 120 degree for all of them. So like this, you can construct a hexagon with 6 sides, a regular hexagon. Once you construct regular hexagon like this, now they want to construct a circle circumscribing a hexagon. Means circle should be outside the circle, hexagon. Means it must touch all these points or vertices of a hexagon. Do one thing, you bisect one side. For example, you bisected BC, and you got this line as a perpendicular. You know that this is a locus of points, equation from B and C. Similarly, bisect one more side like AB. When you bisect lines AB, you get one more line, locus of points. This is equation from B and A, where both of them come and touch. This is O. This is a point O, which is equation from C, B, A. Not only C, B, A. Since it is a regular hexagon, it is equation from all these 6 points. So keep it as a center. Take either C or B as a radius. Draw a circle. The circle will touch all these vertices. Are you getting it? Bisect any 2 sides, 2 points. See, this line and this line, or this line and this line. Where they meet, that is the center O. Keeping that as a center, B as a radius, draw a circle. Or C as a circle, radius, draw a circle. So all the traces of the construction will be clearly shown. No matter the steps in the exam, the construction should be able to explain how we are constructing it. Now, construct a triangle ABC with BC 6.5, AB 5.5, AC 5. Hope you remember all this construction you had done in the previous classes, especially in 7th and 8th. So draw bigger side, maybe BC is 6.5. Then BA is 5.5, keep it on B. Draw an arc for 5.5. Then AC is 5, keep it on C. Draw an arc for 5 centimeter, where both of them touch. Join them. So we got a triangle with 3 given sides. Hope it is simple, because already you know. Even in the H1 only you did the circumcircle and circle. Now only extra thing is that why it is like that we are going to learn now here. Construct the incircle of a triangle. Circle should be inscribed. What you do is, you bisect this angle. Take this angle, bisect. Means this is a locus of points. Equation from this line as well as this line, right? This is a locus of points. Equation from this line as well as this line. Similarly, bisect one more angle. Maybe this angle, if you bisect, see it is coming like this. If you extend it like this, this is the locus of points. Equation from this and this line, between these 2 lines, where both of them go and join. This is the center of the circle. If you do it for this, they all come and meet over here. This is the center of a circle. Now I must get a perpendicular from this point to either BC or AC or AB. So let us get a perpendicular bisector of BC. So if we extend it, you can see that it is passing through this. Now keeping this center, where it is touching this line, that has a radius, draw a circle. It is very simple, the incircle. Now I think we are understanding why that incircle will come like this. Because this is a locus of points equal from this line as well as this line. This is a locus of points equal from this line and this line. Means where both of them touch. This point is equal from this line, and because of this line, it is equal from these 2 lines. So this is the equation from all these 3 lines. But very important is, you must get a perpendicular distance from here to this. Take this distance and draw a circle. So you get a circle. Now in the exam they say measure and record the radius of the circle. They know exactly what is the answer of it. So if you tell them what is the radius of it, then they will know whether you have done it properly or not. It's 1.5. 1 millimeter, that side is fine. And they can make out, see whether it is touching all 3 sides properly or not. By looking at that also they can make out is it perfect or not. Please stop it here and practice construction of a triangle, practice the bisection of an angle, and practice the bisection of side even. See, bisection of side is BC is there here, all will touch over here. Keeping this as a radius, draw a circle. Hope it is clear. Practice it by stopping it. Now, using a ruler and compass only, construct a triangle ABC with following. AB is 3.5, BC is 6, CAB, this angle is 120 degree. Last time all three sides were given. Here one angle is given. First let us construct the triangle. BC is 6 centimeter. BC is 6 centimeter. Then draw an arc like you saw in the hexagon construction. Draw an arc, 60 first cut, then 120 this other cut. This extend this line. Then measure 3.5, keeping it here, cut. Now you can complete your triangle. You got your triangle with 6, 120 degree and 3.5 centimeter. Draw a circle with BC as the diameter. BC should be diameter. Means you must draw a perpendicular bisector of this so that we get the midpoint of BC, that is O. So OBLB is equal to OC. So see here, side bisection is there. Bisect it. Angle bisection is different. The side bisection is there. Keeping O as a center, B or C as a radius, draw a circle. See, circle is drawn over here. Find the point P on the circumference circle which is equidistant from AB and BC. Which is my AB? AB is here. Where is my BC? BC is here. We have to get an angle bisector of this because this is a locus of points equidistant from both these two sides, right? So bisect this angle. Actually already we know it's 120 degree. This is 60 degree is there. So extend for the 60 degree. Where it touches my circle, this is the point which is equidistant from both my BA and BC sides, and it is on the circumference of a circle. So mark this P and join them. You get a point P on the circumference of a circle. Measure BCP. Measure BCP. See, one more thing I'll tell you. We'll go to learn in the next chapter. Angle in a semicircle is 90 degree. So BC is a diameter. So angle in this side is 90 degree. Actually, if you measure, this will be 90 degree. And this side already we have got it as 60 degree because total was 100 degree. This is 60 degree. So left out is 30 degree here. Your answer should be 30 degree. Otherwise, something wrong with this. Stop it and practice there, and then you practice and continue. Each and every step is given over here. Go through the steps. You can understand if you are not able to follow whatever I said. Otherwise, repeat the video. You can understand the steps. Now, I will once again, now, one more simple construction. A straight line AB is 8 cm long. Draw a line AB 8 cm long. Located by construction the locus of points which is equidistant from A and B, always 4 cm from line AB. This is my line AB. They want a locus of points which is 4 cm away from AB. That's the reason in the beginning I showed. One line is given. We have two pairs of one pair. One side line is this side, one line is that side, which is 4 cm away from this AB. See, this is an arc. Here, you keep somewhere over here. Use your compass, measure for 4 cm and draw an arc. Somewhere here you keep, draw. Then join the tips of them. This is the locus of points 4 cm away from AB. Similarly, keep it over here. And the same thing as I did before. And join the tips of it. This also is 4 cm away from AB. So these two lines are 4 cm away from AB. Now bisect the side AB. Perpendicular bisector you will get, which also will be 4 cm away from this now. The point. This point is 4 cm away from it. Actually this is, I can take this as a CD and I can take this as a EF. Now where it touches, you join. You get a figure like this. Already you know this is 4, it is 8 cm total. And this length is 4 cm. Down also is 4 cm. Means this diagonal is also 8 cm. Both the diagonals are equal. Since both the diagonals are equal, it is a square. And this all sides are equal, you can measure it. And if the diagonals are also equal, so since the diagonals are equal, I can say it is a square. By chance the diagonals were not equal, one is 8, other one is 6, then you would have gone for a rhombus. So that's the main difference between rhombus and a square. Square diagonals equal, rhombus diagonals are not equal, but in both rhombus and square, all the four sides will be equal. Hope it is clear, right? Practice it, then continue. Now, draw a circle of radius 3.5 cm. Easy now. Assume this is my circle. Draw a circle keeping the center. Draw a circle with 3.5 centimeters radius. Mark the point P outside the circle at a distance of 6 centimeter. Keep the center. Mark somewhere 6 centimeter away from this center. Construct two tangents from P to give the given circle. You have to get two tangents. Actually, tangents are equivalent from the for the circle. Now what we do? This is 6 centimeter away from the center, right? Now bisect this length. Means this will be 3 centimeter away from this side as well as this side. You bisect this from here and here. Join them. See where the midpoint of it. Taking this as a midpoint and this side as a radius or this side as a radius. Draw one more circle. You draw one more circle like this. Once you draw a circle, make out exactly where it is touching my line over here and here. Keeping this as a point, extend that line. And this side also you extend the tangent. Means both of them are tangent because it's touching only at one point. This is a way to draw a tangent from outside a circle. First draw a circle. Once you draw a circle, what are the distance they mentioned from the center? You measure and mark. Join them. Draw a perpendicular bisector of this. You get a perpendicular bisector of this. Keeping the center, draw one more circle. Dotted circle is better. Then where it touches those 2 points, extend it. This is the tangent. Now they ask us to measure the length of the tangent. If you measure PQ as well as PR, length will be 4.8. Try doing it. Is a useful one, very simple one. Construct a triangle ABC in which BC is 6 cm, means base is 6 cm. AB is 5.5 cm and this angle is 120 degrees. So first draw BC, draw an arc 60, 120. Extend for AB 5.5 cm, you mark. So you got a triangle with whatever the measurement they have given. Construct a circle circumscribing the circle. Last time we did the incircle. Now a circumscribing the circle means it must pass through these three vertices of my triangle, right? So let me bisect this BC side. When I bisect this BC side, we get this locus of points. When I bisect this AB side, I get the locus of points. Where both of them intersect. Where both of them intersect. This is the point equidistant from A, B and C, right? This will be equidistant from A, B and C. Keep this as a center, either A, B or C as a radius, draw a circle. We get a circle like this. Draw a cyclic quadrilateral ABCD so that D is equidistant from B and C. Where is B and C? B and C is this line. The perpendicular bisector what you have drawn before, you extend it till the circumference here. Once you extend till the circumference, then this is my D. Join them. And you get a quadrilateral. And it is known as a cyclic quadrilateral. Because all these four vertices of a quadrilateral are lying on the circumference of a circle. Same things are explained over here. Go through either my explanation or go through the steps. Just follow as such. Now, draw a line AB 5 cm. See, draw a line AB 5 cm. Mark point C on AB such that AC is equal to 3 cm. Keep at A. Mark for 3 cm here. This is your C. Using and draw compass only. Okay. Now construct a circle of radius 2.5 cm passing this A and C. Now bisect this AC. You are getting a locus of points. You are getting a locus of points which is equal from both A and C. You have got it, right? Now, since you can keep anywhere to draw a circle which will pass through A and C, but they want to draw a circle which is 2.5 cm in its radius. So keep it over here, A or C. Cut for 2.5 cm. We get O over here, the center of the circle. Because this is 2.5 cm from A as well as C. So keep it over here. This is the radius, 2.5 cm is the radius. Draw a circle. You can draw a circle with 2.5 cm passing through A and C. Now construct two tangents to a circle from the external point B. So Already we have a B. So see, already circle is there with us. B is the external point. We got the center of this circle. Now draw this line OB. Bisect this side OB. We get a line like this. This is the center of the perpendicular center of OB. Now keep B as a center. Draw a circle. When you draw a circle, it touches in two different points. Now where it touches, from B you extend that lines. From B you extend the lines. These are the two tangents for this circle. See, tangent concept is covered. Circle concept is covered. A lot of things are covered in this chapter, in this question. Go through the video once again, or just try to follow the steps once again. Now, using ruler and compass, triangle ABC, in which AB is 5 cm, 5.5, BC is 3.4, CA is 4.9 centimeter. Locus of parts is from A and C. So let us take AC first. Then we will mark for from here 5.5 we will cut, 3.4 for it. We got a circle, we got a triangle. Once you get a triangle, now we had locus of points from A and C. Bisect this side AC. We had a locus of points from A and C. A circle touching AB at A. Circle touching AB at A and passing through C. Circle touching AB at A. This is AB, means AB is a tangent. It should touch, this is a tangent. It should touch at A and it should pass through C. Means if from both of these 2 points, we must take a point. So we know that always tangent makes 90 degree with the center. Please understand, please remember. How to know how much has angle? It should touch AB at A. Means a tangent is made over here. So draw an arc from here 60, 120, bisect the 60 and 120 to get 90. You extend where it touches this line. This is my center of the circle. So this is center of the circle and this makes 90 degree with this, which means it is a tangent. Even tangent always makes 90 degree over here. So keeping this as center, if you draw a circle, it will pass through both A and C. Is it okay? So we are getting a circle which pass through both A and C. Two things we are remembering here. They clearly said touches AB at A, means at this point a tangent is made and should pass through C. So this is the locus of points equal from both A and C. Should touch, means 90 degree should be made. So A, you can start from here directly and you can continue 60, 120, bisect the 60 and 120. You get 90. Keeping here cutting, from keeping here cutting, extending it where it touches the center of the circle. Take A as a radius, draw a circle. Now, using the ruler and compass, consider triangle ABC, in which AB is 7 cm, CAB is 60 degree, and AC is 5 cm. So first draw this, draw an arc for 60, draw an arc, cut for 60 degree, extend this line, measure for 5 cm and cut. So we got a triangle with whatever the measurement they have given. Now point equal from AB and AC. AB is this, AC is this. Bisect this angle, because these two sides they have given. Bisect this angle from here we extend this line. This is a locus of points from AB and AC. Points equal from BA and BC. BA and BC. Once again bisect this angle. Draw an arc. See, from here he has just shown outside the triangle. From here is keeping and cutting here. It is extended like this. Both of them are touching here. Means this is a locus of point equal from all these 3 sides. Now once again draw a perpendicular bisector or extend this so that you get a perpendicular bisector over here. Keeping this as center, this is a radius, draw a circle. Otherwise, from keeping it here, you must draw an arc. Once again keeping here, draw this. From here, draw this. Extend it to the perpendicular bisector we get. Then once again, this is a radius, you can complete the circle. So this is a way you need to practice the construction of a circle. This actually we have done in A standard, in circle and circumcircle. The same thing is repeated. Only thing is that they don't directly say in circle, circumcircle. They say bisect this angle, indirectly saying that it is from AC and AB or BA1 BC. And this is a locus. It's a common point equal to all these 3 sides. Then use ruler and compass only. It's always ruler and compass only. You can't use a protractor. That's what it means. You can use pencil, sharpener, rubber and all. Not use a protractor to measure 60 degree and 120 degree and all. So construct an ABC with BC 6.5. First draw that line. 60 degree, draw an arc, cut for 60 degree, measure BA 5 centimeter, extend that line, cut for 5 centimeter. Now you can complete this triangle. Locus of points at a distance of 3.5 centimeter from A. A is here. See, what a 1.3.5 centimeter. See, this is the locus of point. A circle has come. A circumference circle has come. This is 3.5 centimeter away from my A. Now, construct a locus of point from AC and BC. AC and BC means C is the common vertices for both of them. Bisect this angle from here here. Extend. This is extended line. Mark 2 points X and Y which are at a distance of 3.5 centimeter from A, because this is the locus of points which is 3.5 centimeter from away from A and from A and also from AC and BC, this line and this line. So this is the locus of points taken from both the lines, as well as it is 3.5 centimeter away from this A. So these are the 2 points. Measure XY. You use a scale and measure how much is the length of this. So according to him, we should come to 5 centimeter. That they will be knowing the answer. By that they can make out whether the answer is right or not. Okay. So these are the constructions which are familiar to you, which you have learned in 8th standard and 7th standard. Now only the extra word is locus. So you must be able to understand the word locus properly. First of all, basically whatever I said in the beginning 2 screens, you understand that, then it becomes very simple for you to solve these questions. Understand and solve, things becomes very simple. All the best.